Hi, my name is Austin Bernard, and I'm going to be talking about the adaptability of humans. So I'm going to start off with talking about what it means to be human according to the Center of Humans in Nature. They say first, to be human is to have the ability to communicate systematically using words, symbols, body gestures, posture, and facial expressions. 2 is to make your own decisions and bear the consequences of them. 3, to make and wear clothing, accessories, and other necessities for human life. 4, to become individuals in the process of making our own life and what each one of us want to be in the future. 5, to think about thinking and to ponder on the past, present, and future. Basically, to think, therefore I am. 6, to fit into different personality groups, but our experiences with the personality type is special and different within ourselves. 7, to fit in different racial, cultural, religious, and political groups. 8, to have a government. 9, being unique as an individual in our choices of who we want to be as a person, in our clothing, preferences, talents, gifts, perspectives, likes and dislikes. 10, to live in an economy. 11, to inherit our genes and behavior from our parents, grandparents, aunts, uncles, and great-grandparents. 12, to be unique and special as a species. However, in my opinion, there's no limit to what the qualities are that make us human. So I'm going to look at 3 different artifacts. First one's going to be the Trap Cave 3D specimens. Then it's going to be the University of Wyoming Geology Museum, and the College of Engineering and Applied Science. So to start off, this is a cervical vertebra from an Ovis canadensis, or a bighorn sheep. And then we have a metatarsal from that same species of bighorn sheep. And then we have an ulna again from that same species. Next we have a forcula, which is from the aves species or bird species. Then we have an equus tooth or horse tooth, and an equus femur, again a horse femur. And then we have an artiodactyla lumbar vertebra, or the vertebra from a cloven hoofed animal, in this case looking kind of like a deer. And then we have a legomorphia inanimate, which is a rabbit. And then we have a mammalia thoracic vertebra, it's basically just from a general mammal. And then we have a canis lupia tibia, or a wolf tibia. So what do these fossils tell us? They tell us what life was like for humans in the past in this region, and how we've had to adapt since then. These fossils show us what animals lived in this region, as well as possible food sources for humans. As humans, we've had to adapt our hunting methods from hunting these smaller animals like rabbits to hunting these bigger hooved animals like sheep and deer. When hunting these bigger animals, we've had to develop heavier weapons in order to actually hunt and kill them. Then it also gives us a look at what it took to survive, what type of animals were actually able to live in this area, as well as what humans had to eat in order to survive in this area. Next we have the University of Wyoming Geology Museum artifact. So first we have a Allosaurus, or a different lizard, who came from the time of late Jurassic, which is about 145 to 155 million years ago. It came from the geographic range of Wyoming, Montana, Colorado, New Mexico, South Dakota, Utah, and Oklahoma. It weighed about 1.5 to 2 tons, and was about 30 to 40 feet long, and lived in plains and lowlands. And then we have the Apatosaurus, who came from, again, the late Jurassic, 145 to 155 million years ago. And this guy was found in the Morrison Formation rock, and it came from Wyoming, Colorado, Utah, Montana, and Oklahoma. It grew to about 80 feet in length, weighed to about 30 tons, and was a herbivore, and it lived in lowland floodplains. Next we have the Diatrema gigantea, or the giant bird. who was from about 55 million years ago, or the early Eocene. Came from the geographic range of Wyoming, New Mexico, Colorado, New Jersey, Canada's Ellesmere Island, France, and Germany. Its height was about 7 feet, its skull length was 1.5, and weighed about 385 pounds. It lived in lowland floodplains as well, and was a carnivore as well as possibly a herbivore. Then we have the Triceratops, which is actually a Wyoming state dinosaur. Came from the late Cretaceous, 65 to 70 million years ago. Ranged from Wyoming, Colorado, Montana, South Dakota, North Dakota, Alberta, and Saskatchewan. Weighed about 5 to 6 tons, and was about 30 feet long. It as well lived in lowland floodplains and was a herbivore. So next is the Stegosaurus. The artifact didn't have too much information on it, but it did say that it was an unusually looking dinosaur with a very long neck found in the Morrison Formation of the Rocky Mountain West. Then we have the Tyrannosaurus rex, which came from the late Cretaceous, 65 to 70 million years ago, and was found in the Lance Hell Creek Formation rocks. Was found in western interior of North America. Grew to about 15 meters in length, 6 meters in height, weighed about 7 tons. Was a carnivore, and as well lived in lowland floodplains. So the importance of these fossils, there's so much we can learn from fossils, and even though there weren't humans at the time, the presence of these dinosaurs show how the ecosystem of the earth has changed and had to adapt to new situations. The study of fossils like these demonstrates a key aspect of being human, and that is a thirst for knowledge. As humans, we want to understand our past so that we can not make the same mistakes in our future and to better our future. The studies of fossils are essential to understanding evolution and where we come from as humans and how we have adapted to our environment. And lastly, we have the College of Engineering and Applied Science artifacts. First, we have the graphene oxide film graphitization via laser patterning. Graphene oxide can be treated with lasers to create patterns of conducting carbon within a surrounding environment of insulating materials. This allows us to create nanoscale circuits in thin sheets of materials, which enables next generation devices. Scientists apply techniques from artificial intelligence to achieve the necessary precise control. Basically, humans aren't able to be this precise in making these nanoscale circuits, so technology has developed in order to take that over. As humans, we've had to adjust to technology taking over a field in certain jobs, and we've had to adapt and evolve in order to remain relevant. In this case, by implementing new education systems so that we can maintain these machines that are actually building these circuits. Then we have composite failure prediction. This is determining the limits of forces before they break, and this is an important problem for engineering and manufacturing to solve. The field has developed a number of failure criteria, and these functional forms are not very flexible. They require significant experimentation with new materials in order to be determined, and we cannot have science without experimentation. Experiments often fail, requiring us to adapt our hypothesis and experiment and try again. This is actually another important aspect of being human. We learn from our mistakes, and we cannot advance without failing and improving on our mistakes. Then we have nature-inspired impact-resistant materials. So composite microstructures observed in nature serve as templates for the development of new synthetic materials. Rather than attempting to replicate these materials or biomimetics, the focus of this work is to use the bio-inspired pattern generation algorithm, which was optimized by Bayesian methods from artificial intelligence, to design new materials with high energy absorption properties. And we have learned that nature has evolved and adapted over millions of years in order to best suit its environment. Therefore, that's why we use nature as an ideal model, because it's had millions and millions of years in order to build the best model and best way to suit its environment. Next, we have the AIM Center was awarded NASA grant for manufacturing flexible electronics, which can be used in clothing, as well as prosthetics for disabled and wounded people. An AIM workshop at the Materials Science and Engineering Symposium. So AIM stands for Artificial Intelligent Manufacturing, and AIM Center organized a workshop on AI and advanced manufacturing, which was co-located with the 2019 University of Wyoming Materials Science and Engineering Symposium. AMPI and associated researchers presented the latest results on applying state-of-the-art AI to laser-induced graphene production, atomistic modeling, and porous media modeling. So what does this advancement of technology tell us? With advancement of technologies, humans have had to adapt, not only their everyday lives, but education. Especially in this era with COVID, we've had to push to a more technological and digital world in order to interact with others, because we haven't been allowed to actually interact in person. It's also had us adapt our education. Rather than just learning to make the materials, we are learning to maintenance machines that make these materials, because these machines are actually providing much better efficiency than humans are. Advancement of technology provides increased efficiency, which in turn requires less people hunting or making clothes or things that are essential for life nowadays, which gives humans more time to find their passions and actually make things that give our lives purpose. As humans, we want to understand our reality, and technology has allowed us to adapt to a changing environment and better understand our reality. In the instance that advancement in microscopes has allowed us to more closely examine atoms, so that we can understand different aspects of physics that we couldn't without that. There are risks, however, with this advancement of technology, especially in the field of AI and robotics. There are risks to our humanity. We can lose touch with others and our human connection to others, especially when we're moving to this more digital world, because we cannot interacting with others on a physical world. As we travel toward a world more reliant on the digital world, we become less in touch with the physical world. And this is something that ties us to our human bodies, which is a big part of us being humans. So I have a question to leave you guys with. Will we be able to adapt fast enough to keep up with technology and AI, or will we have to sacrifice some of our humanity in order to do so? And then here is my bibliography.